ladies and gentlemen. Hi, today I'm going to talk about your path to edge computing. This is important for many telcos, hyperscalers, IoT, and enterprises. Okay. So what is Akraino Edge Stack Blueprint? So it's kind of before Akraino, all the software developers has to download the software packages from the upstream communities and integrate and test it. But with Akraino, we have the Akraino Blueprint, this kind of concept. You can do the community integrated, tested, deployable, end-to-end edge stack. That's what we are for. So all of this blueprint is use case based. You can have 5G, AI use cases, and it's fully integrated end-to-end solution. We call it CI/CD. And it should be proven and tested by the community. We have Akraino Community Lab. We also have the validation lab for each blueprint. The blueprint's validation lab is connected to the Akraino Community Lab. And also we do the lifecycle support for the whole community. There is something called the Akraino Blueprint Validation Framework project. It's a feature project which defines the different levels of the validation for each blueprint. You can test the hardware, you can test the OS, you can also test the Kubernetes from their like conformance testing. And finally, there's a production quality provided and also deployable, deployment-ready blueprint. So what benefits can we get from this? Because this is low cost and this is open source. And it's also because you have already done the verification and also the integration and tested in the community. It saves a lot of CapEx and OpEx from the end users. Also, you can deploy the larger scales because you can use, like for example, Tencent, we'll talk the next. They have their larger scale deployment in China. In this case, you can connect the different labs into a larger scale testing format. And also the zero-touch provisioning, we have cloud automation. We have all kinds of automation all working. We use ONAP as an orchestration, and there are the other flavors of orchestrators. Importantly, there is an industry adoption because a lot of end users, they participating from the user point of view. In this case, you can adopt for the industry like Elliott, Edgelight, the IoT Blueprint family, and like the ICN, it has been adopted by multiple industries. Finally, when you talk about the hardware, we use OCP, white box, and OEM hardware there. So last week, there was the ICP Regional Summit in Amsterdam. People present the open edge for the edge hardware specs. So there were Akraino related like a rack telco appliance there presenting and also demo and showcase there. It's very successful and interesting. Is there any, like, how do I flip remotely? Okay, here you go. In June 6 this year, we released the first release 1 here. The purpose is to unify the edge with a robust community contribution from across the globe. You can see we delivered 10 blueprints for a variety of edge use cases. It addresses telco, enterprise, and IoT edge use cases. All blueprints were CI/CD tested in lab. From left to right, you can see the gateway, thin or thick kind of gateway. As I mentioned, the Edgelight IoT with the IoT gateway, which can be used for the like a smart office in the building, AIoT, or UCP for SD-WAN cases. Furthermore, you can see REC, Radio Edge Cloud, which is the controller for RIC. RIC is called Radio Intelligence Controller in the ORAM terminology. It's located in the industry and telco radio edge appliances. We call it HCI. And further, you can go to the mini DC edge. There is IEC, Integrated Edge Cloud, with type 1 for small deployment and type 2 for medium deployment. I will talk about this in the further slides. And going forward, you can see the far edge Starlink X distributed cloud. This is on the on-prem and DC edge. It's taking the Starlink X from the upstream community and integrated it for the far edge use cases in Akraino. There's another one called Provider Access Edge. This is part of KNI, the Kubernetes Native Infrastructure Blueprint family. This is the one for release 1. They have another one for release 2. This one can take the Kubernetes basics infrastructure, Kubernetes native infrastructure for the provider's access edge. And even higher, you can see the Unicycle and Rover for the network cloud, for the telco or the cloud edge. Unicycle is a rack with like 6 to 7 servers, like 3 for control node and the others for compute node. And Rover is more like a far edge, only 1 server there. But using network cloud, you can do the multi-site configuration. Any questions so far? Okay, so let's move on.
Are these in Terraform, or are they in, what are these blueprints written?
Oh, okay. So they're written in C++, Go, and Python. And for the installation scripts, there are YAML file you can install. All right, we have release 1, and now let's talk about release 2. Every 6 months, this is the cadence of Akraino releases. Release 2, it's more like enable the industry applications. So there are supplier or blueprints to ORAN, ONF, ONAP, LF Edge, and other communities. You can see we do some enhancement, like for NC, Network Cloud, for IEC, Integrated Edge Cloud, and we have more blueprints, like the KNI I mentioned earlier. The community lab and validation, we have more validation lab and more donation. Thank you for Intel, today's host, have a lot of Intel servers donated to the community lab. Also, we do some mandatory security and conformance testing. The security we take, where was that? Sonar Cloud as scanning tools statically for our code. And also the conformance testing we did, and it's a Kubernetes conformance testing in the Blueprint Validation Framework project. We liaison to all of this ORAN, ONF, all these communities, and even encourage the blueprint, like a CBA blueprint, if they are having any patches to the upstream community, they have to go to upstream community to do the merge of the patches. Finally, we have the API specs. There are 2 work streams on the API subcommittee. One is called developer-facing APIs. The other is infrastructure APIs. There are 2 kinds because we have both, like a lot of big companies, they're doing infrastructure. And the other side, we have like slightly smaller companies, all the developers, they are doing all of these developer-facing APIs, like for location services, for 5G, for MicroMac. By the way, we have a hackathon at the day 1 of KubeCon, hosted by Qualcomm. It's the MicroMac hackathon, jointly sponsoring by Akraino, Linux Foundation, and also ETIMAC. So if you want to know more about the community lab, this is the link of the community lab. There's community lab and additional validation lab in New Hampshire University. Let's see what we have. Okay, so let me talk about a little bit about the ORAN enabler. So how many people are involved in ORAN? Raise your hand. Okay, so we got 2 people. Okay, so they'll talk about more. So ORAN is a RAN disaggregation. You can see all kinds of virtualized network elements here. There's white box hardware on the bottom, but it provides the standardized interface. From bottom, you can see the RAN RRU, then there's open front hall going to the the RAN DU and CU is separated from the BBU. Then going up, you have this RAN intelligent controller. We call it RIC near RT. In the next page, I'm going to show you how Akraino rack is controlling this RIC. There's a A1 interface which connected with the ONAP as an orchestrator. There are it does the design, inventory, policy, configuration, and RIC non-real time. So this is still under discussion within the ORAN organization. So Akraino Community Blueprints can supply the end-to-end edge stack to support this NFVI as per the ORAN requirements. So next page is going to show us how we are doing that. So this is Akraino R1 already released from June 6, the rack. So rack taking this, there is a portal. Then we take this regional controller. Regional controller is, let me take it. The regional controller is feature projects on the Akraino. So it can be used for several blueprints, but the first use is from the rack. So we have the remote installer is important. You also do some like hardware management. From bottom, the hardware include 5 flavors, currently both x86 based and ARM based. There were like several vendors, like 5 of them already attending, but the basis is OpenEdge. The OCP OpenEdge, it has to comply with that. If not, eventually it will comply with OCP OpenEdge. But going up, you have to support the L-ship 1.0, but this is in the future. But today, it runs like on Kubernetes and Docker and Helm, Denim plus, let's say, SRIOV. So Denim plus SRIOV will give higher performance compared to the Flannel. So the middleware and MPI APIs, the RIC parts, this is all the known you can imagine. So what's the benefit for rack? It's fully integrated appliances to address all RAN requirements. We have a feature channel set up, and next page I'm going to talk about that. And it's also fully automated zero-touch provisioning because we tend to use A1 interface to use some components from ONAP to do that. And also x86 and ARM supports the OCP white box, and the OEM also support that for the hardware part. Any questions for rack? So as I mentioned, the official liaison has been set up between ORAN and Akraino. So the ORAN working group, so they made the requirements and specifications. Then it inputs into Linux Foundation community wiki page and the Jira system. In this case, it goes into Akraino community blueprints. Also, the ORAN code can be integrated into the blueprints, like REC is one of them. We may have more in the future. And at the same time, the software and hardware from upstream communities will be integrated into blueprints. The software examples include Kubernetes, ONAP, etc. The hardware will include like OCP and all kinds of OEMs hardwares. After we have this Akraino community blueprints, it's mandatory for the Akraino blueprint validation and lab tested and deliver. This is all mandatory. And at the same time, the ORAN SC will do the additional integration here and then give the feedback loop back to the Akraino validation lab, the validation framework project. After the ORAN SC does the additional integration, it was input to the end-to-end certification, which is called ORAN TIFF group. So finally, a feedback to the user. I see this is a complete closed loop between ORAN and Akraino. Any questions so far? Okay, seems clear. All right, so I'm gonna highlight some of the integrated edge cloud blueprint family. So the IEC can run as individual blueprint or stack, or as a component within the other blueprint to support the ARM architecture. And also it actually both support ARM and or x86. It supports mainly cloud native. So from bottom, you can see the network equipment, the switches, gateways, and then the network edge platform, or you can call it edge servers. It does all kinds of hardware acceleration. It can do integrated accelerators, SmartNICs, FPGAs, and GPUs. Above that, there's Linux distros, and then SIOV, DPDK as data plan. Above this data plan, you can see you can do the infrastructure orchestration and installer like Kubernetes or Fuel or containerized Compass. For the networking software, we can do the next system networking like VPP from FIDO, like OVS. Controllers, there are many choices like Calico, network service mesh or X connector from VMware. Also, the Conti VPP also provide another kind of controller here, and as well as the OVN Kubernetes. About that, you can run different flavor like Knative, Kubeflow, and EdgeX. Like EdgeX is for the IoT things. All the applications can run either on the bare metal or the containers. So here, the lightweight app orchestration means some subset components from the ONAP. Any questions?
Can they run VMs as well? Or?
They can, but current version doesn't support VM. This is what ARM architecture support on Radio Edge Cloud. I highlight several parts. The remote installer, the enhancement is to do some ARM packages for that. For the CentOS, it supports the ARM images and packages. For the hardware management, it supports ARM solutions. This is all kinds of enhancement if it runs on ARM. Currently, it works on x86 today. Okay, the IEC cloud platform enabler used by multiple blueprints. You can see telco appliances is a bunch of reports, thousands lines of code to run telco appliances. Like you have this ISO images, then you run rack. We just explained rack, and you run SIBA. It's like a software-enabled blueprint. Software-enabled broadband access. It's mainly for the control plane of the white box of OLT. It can partially run in TA or IEC as IEC cloud platform. And also Micromag is mainly for the smart city. What I mentioned about the hackathon is based on the Micromag. It has both device side and server side. And IEC Type 4 is more like a use case and applications running AR, VR edges. Then connected vehicles, I think Robert will talk the next topic, running Tencent's connected vehicles with stars as a microservice framework, running not only connected vehicle, but also like Tencent videos and Tencent gaming there. The AI Edge was originally proposed by Baidu. I think it will be followed up by WeBank and the other Baidu autonomous, something called Robot Taxi, which is deployed in Changsha in China today, like really the autonomous taxi on the road. And the last one, not the least, the list not the last. The 5G Max slice is proposed by Tencent and China Mobile from beginning, but some other companies also be part of it. Intel and ARM are part of it, the blueprint. It's like China Mobile provided the B2B 5G services, Max services to Tencent. With these services, this year running release 15, next year running release 16, with the higher bandwidth and lower latency, they can run the HD video, they can run the live streaming, and they can also run cloud gaming. The really full-blown of 5G next year, but this year already started running based on release 15. Okay, I think this is the last page of my. Okay, we still so talking about so many. You may ask, how are we gonna involve into Akraino? So in Akraino, you can join the project's mailing list. We have the mailing list here. You can join like a technical discussion list or TSC list or blueprint list with a hashtag. Then you can go to the different blueprints. You can subscribe to the feature project list. And there are also 7 subcommittee list. Like Strata is the documentation subcommittee chair. And we also have the API, security, CI, and process, technical community. I may miss something, and please remind me if I miss anyone. Also, you can join Akraino community events and project course. Here are our calendar, the community calendar you can follow. And also, Akraino project, TSC, and community course are open to everybody. You don't need to have a membership to join this course. It's open to everyone. There is something conducted every Thursday, 11 a.m. at Eastern Time. It's called the Technical Community Call. We'll have a deep dive or to answer all kinds of questions if you're a newcomer or you think about, I want to have my own blueprint, I want to propose something, feel free to raise it. And you can also find a website which will show the 10 blueprints from R1 as a landing page currently. The wiki records the current progress of Akraino. The mailing list I just talked about, and all the blueprints, approved one is here. Next to it, you can find the proposed blueprints. I think that's about it. Okay. Any questions? Open to the floor. Yes.
The 5G Mac.
Sure.
That's open source?
Yeah, there are 3 parts. If I can record, like the purple part is from the 5G core. They will use some open source simulator to simulate what the operator provided to them. And they provide something called Edge Connector, and also the Edge Gateway is the open source from Tencent. And for the infrastructure part, they use either IEC as an edge infrastructure or ICN as an infrastructure, edge infrastructure. Does that answer your question? Thanks. Okay, that gentleman. Okay, sure. So the IoT use case, oh my God, I forgot to put the ELAT here. Yeah, that's the most important one. So the IoT use case, so for the IoT gateway, it can be used, they have 3 blueprints under the same blueprint family. The first one is called IoT gateway. It's just the normal use of IoT gateway to translate between different IoT protocols like Zigbee, Z-Wave, Bluetooth Low Energy, all of this into the protocol the upper devices can understand. And the second blueprint is called UCP SD1. It's mainly used for the SD1 use cases. The UCPE concept is quite widely used in the industry. And the last one is interesting is Tencent deployed their AIoT in the smart offices in Tencent's all the buildings in Shenzhen, their headquarters. like when you walk away from the meeting room, it's automatically released, and all of these things you don't have to worry about to book or click anywhere. It's just automatically using the sensor to sense how many people in the room, like whether it's really used. I think that one is in deployment today. Yeah. Yeah. She's looking at me. Any other questions? Yeah, go ahead.
From an ARM perspective, any effort, just curious, just curious, anybody working on taking this stack and then taking to like like, is it ARM 6, ARM 7, are there any minimum level as well as specific industrial boards such as, for example, like a Raspberry Pi for industrial application? Curious.
Yeah, all the flavors on VA, on V9, and for the edge servers, but Cortex A and ARM, all of them are used for different use cases. Like Micromac will use Raspberry Pi. Guess what? In the hackathon in KubeCon, we use Raspberry Pi for that. But like ARM7. Yeah, anyone works. Yeah, like depends on like the scale and positions in the network. But edge computing comes from all the way from edge to cloud. It's from the local services we call gateway, and even the devices for IoT devices, to the local service gateway, to the infrastructure service, to the edge service, below the private and public cloud. Yeah. Other questions?